Good morning, everyone. Today I'm going to explain my 1.1p, which is proof of the concept of moon robot simulation, which means the surface of the moon can be represented as a square grid of size n. For this task, I've made a class moon robot of course contains five private variables. In this task, as per the instructions, we have to simulate a robot which is moving on a square kind of moon map of size n, which and it can be controlled by the user using different commands such as move, left, right, and exit. First we have, as I said, first we have made a class moon robot, which can be seen. The first two private int variables, private int position x and private int position y, these are used for storing the position of the robot. The next comes the private string facing directions, which just tells about the direction in which like the robot is there. For example, it can be north, east, west, south. So, and the next comes private bool robot initialize, which is currently false, which tells about, which means the command cannot be initiated before the robot is placed, so it just checks about it. And then next last one comes the private in grid limit, which means the area or the size of the grid. And of course, the grid cannot be as a size of 10 into 20 or 10, 20 into 30. It must be a square, so which means 10 into 10 or 20 into 20, as it's shown here. The other one comes public void set position, and the public void set position, as seen in the it checks for the valid position, and this is a command or a method which checks if the direction is valid, and after checking it's valid, it just sets the robot position as per the input, and uh, sets its position to true, and then displays the current status. This command basically is used to display the current status. If the command is invalid, for example, position or the direction position basically is inputted invalid by the user, so it will just display an error message, which means invalid place command. The next comes up the move forward, which is a different method. First it checks if the robot has been placed for sure, and then it calculates the new position based on its direction. North increases by, south decreases by, east increases by x, south decreases by y. And it prevents basically the robot from falling off the map. Next comes the rotate left. Public wide rotate left, it just rotates. And of course the public wide rotate right, it just rotates the robot, which are the basic commands. Rotate left rotates the robot in anti-clockwise direction, and the rotate right rotates the robot in a clockwise direction. For example, if a robot is facing north and a rotate left command is inputted by the user, so of course it will move in the anti-clockwise, and rotate right will definitely move in the clockwise direction. And then comes show status, check valid position, and check valid direction. Show status, which means it just shows the status of the robot, in which direction it's facing, and of course its position. Check valid direction and check valid position. Check valid position ensures that the robot stays inside the map and doesn't just fall off. Check valid direction make sure that the directions are valid and accepted. This basically improves the safety and ensures runtime, and prevents runtime and errors. Just it doesn't just ensures the errors. And then comes the main, the class program, which once executed, firstly it asks for the user, for the map size. The map size, of course, as I just told, needs to be a square. For example, 10 by 10 or 20 by 20. It just cannot be 10 by 20 or 20 by 30. So which will be definitely a wrong part and invalid input. So then comes the commands like move, left, right, and exit. These are the commands which can be used. I'll just show you once I run the program. So I'm just going to run the program. So I'll just perform the practical now. I'll just run the commands. For example, I'll just enter a size map of 5. So place 2, 3, 4, oh, and the direction, of course, north. Robot is now facing the north. It just turned anti-clockwise. One more left, again anti-clockwise, and I'll just say right, clockwise, clockwise, and clockwise. I'll just say move is facing east. You can just see the change in the direct placement. One more move, of course. It just ignored the move to prevent the robot from falling off the map. So this was my demonstration, video demonstration for performing my task and the code. Thank you.